Well, welcome everyone to today's Cultivating Success webinar. Our topic today is biochar, properties and potential as an agricultural amendment. We're very happy to have Dan Strawn with us from University of Idaho Soil and Water Systems Department. And then we also want to acknowledge that Greg Muller with University of Idaho Food Science has also been active in this research. The Cultivating Success program was established in 2000 by the University of Idaho Extension, Washington State Food Systems Program, and the nonprofit organization Rural Roots. We're really happy to have this be our fourth webinar series. As I said, today's presenter is Dan, and the reason we're talking about biochar today is that you all requested it. We looked at all of our evaluations from last year when we set the topics for this year's theme, and biochar was one of the things people were interested in learning more about. So we're really excited to learn more from our University of Idaho faculty on this topic. Just a couple of quick webinar tips before I turn it over to Dan. If you close all the other programs running on your computer, that could help with your bandwidth. If at any time you're having trouble with sound, it's crackling, it seems slow, the transitions on the slides are slow, please go ahead and type into the chat. Mackenzie's standing by to let you know whether or not those technical challenges are on your side or on the side of the presenter. Another thing is that if you have questions anytime during the presentation, you can put them in the Q&A box, which is at the bottom of your screen in your control bar. It's separate from the chat box, and we'll have time throughout the presentation to ask those questions. This webinar is being recorded, and the webinar and a handout of the slides will be available on the Cultivating Success website, most likely by the end of the day tomorrow. So with that, I'm going to go ahead and turn the slides over to Dan. Welcome, Dan, and thanks for being our presenter today.
Thank you. I'm happy to present today and tell a little bit about my experience in research working with biochar. Let me share my slides here. Okay. Are my slides transmitting okay?
Yes, they are.
Okay, great. So I'm an environmental soil chemistry professor here at the University of Idaho, and I've been aware of biochar for about the last 15 years, and I was drawn into the research on it in a little bit different way in that my colleague, Greg Muller, and myself, we started investigating the potential of biochar to be used for water treatment. And I'll be presenting on some of that research today. But before I get into some of the results of our research, I wanted to go ahead and give a little bit of a discussion of why we are interested in biochar for soils and what the potential of it is for as an amendment to soils. And so I put up this slide just to kind of introduce a little bit more general as biochar as an amendment that you can add to soils and to manage soil health, sustainability, and productivity. So I think everyone's familiar with soil amendments, and they're basically necessary to produce food. We have to add amendments to soil to increase nutrient availability and allow plants to grow. It's always a question of the gain we're going to get from production versus the cost. And there's all kinds of amendments. I did a quick search on the web, and I could probably put over 100 or several hundred different products that you can find. And a lot of these may look familiar to you all, urea, lime, but there's some things that are a little bit more what we call alternative amendments. Things like biochar or what's something called azomite or worm castings or silicon amendments. And by and large, I would guess that most of all of these are beneficial or will do something positive to the soil to different degrees. In some cases, it might be small. And then you have your traditional fertilizers and even things like manure and compost that are added to soils. So before we get into some of the details of the amendments and the one that I'm going to focus on, which is biochar, I wanted to go over a few concepts that I think are important for soil health and management. And I have three basic concepts that I'm going to cover. The first one is soil is complex. The second one is that we can integrate better management to produce healthier soil and crops. And the third one is that we need to adopt long-term goals for agriculture. So I use this analogy of the human system and to try to understand the complexity of systems. And so in a human system, we break it down into all these 5 different components: the digestive system, the nervous system, the circulatory system, muscular system, and skeletal system. But we really know that the human body, all these systems work together. And if one thing's wrong with one part, it often is impacting the other parts. And that to care and treat the human system, we can use medicines. Sometimes there's some treatments that are not so great or have a lot of talk or promise, but really not a lot of delivery. But really, more holistic, healthy lifestyle includes understanding the whole system and caring for all the different elements. So that's my analogy for a system, and then we can transition that into soil complexity. Soils are composed of many different components, and we could break those down into the parts, things like minerals, clay minerals, and quartz sand particles. And there's air and gases in soils, and water in the pore spaces of soils. And there's microbial and microbes and bacteria that interact in the soil, and soil organic matter. And we can study all these different parts, but really it's a system that works together and is very complex and has plant roots in it. And really to manage that system, we need to try to, well, first recognize that it has complexity and try to understand that complexity. And so I've broken this down, or I've used that concept to try to think about how we manage agricultural and natural ecosystems to improve soil health. In traditional agriculture, we manage soil for maximum productivity at the least amount of cost. We generally have this idea: what's good for crop production is good for soil. A lot of times people think soil is resilient. It does have some resiliency, but it also can be fragile or sensitive to changes. We think problems in soils can be quickly fixed. However, in aspirational agriculture, we can manage soil and crops to produce profitable yields. However, it's best to keep an eye towards the long-term health of the soil and ecosystems. We need to recognize that soil is worth investing in because it pays back dividends in terms of production and ecosystem services. And healthy soil practices can create more resilient soil. And that changes to soil health need to be a long-range plan. It's difficult to really change soil health in short time spans. So we're about 120 years into this experiment. I mean, if you look back for several thousand years, we've been cultivating soil and producing plants in agriculture. However, it was really around the turn of the 20th century where mechanization came in and this large, massive scale cultivation of soils and agriculture started. And we've been doing this for about 120 years. And we've caused a lot of changes in our environment, and it's really extensive. I moved here to the Palouse about 20 years ago from a more urban area. And I remember thinking when I was driving through, you could drive for miles and miles and it's all agriculture tilled fields. I mean, in the Palouse, in some areas, it seems like it's almost 100%. There's very little natural landscape left. So we were really doing this experiment where we're continuously modifying our agricultural practices, and we're now at a point where we have some reflection to see, well, what can we do to really have healthier soils? If you look at the overall time it takes to form soils, here's the schematic showing, an immature soil here. It's just basically a lot of rocks. And over time, we start getting some soil developing as those rocks develop. And then you get to a full healthy soil that has all the biological activity occurring in it. And this, these basically soils take several hundred years to form. And really to get to a healthy soil, it can be several thousand years. So if we've been managing soils for about 100 years, we've modified them in a lot of cases, we've improved them, and in a lot of cases, we've done detrimental things to the soil. And we have to recognize that it can take a long time for that soil to really regenerate. So the last concept I want to cover is just basically on soil health and the way forward. We need to increase understanding of soil processes and apply technology for healthy soil management practices. So to improve soil properties such as aggregation, water holding capacity, nutrient availability, the soil carbon, soil pH, natural nutrient cycling within the soil, microbes and invertebrates. And this will result in better water use efficiency, lower fertilizer costs, more productivity, decreased soil erosion, carbon storage, improved soil gas exchange, less disease, and sustainable long-term profits. And overall, a healthy food production services. So back to these amendments, which ones should we be selecting and adding to our soils to produce these healthy soils? What we want to do is we want to add something so we can increase our food production. And biochar is one amendment that's got a lot of interest over the last, I'd say 15, maybe 20 years, and it shows a lot of promise. If you look into the literature, so this is since 2021, basically 6 weeks. In the last 6 weeks, if you look into the literature, 228 papers have been published on this. Over the last 15 years, over 8,000 papers. That just kind of shows some of the interest in biochar as a use for soil amendment. Here's a few products, and I would guesstimate that there's more than 20 or 30 or even 50 different products you can buy that are biochars to add to soils. And so there's a lot of research on this. And the reason there's a lot of research is because there's a lot of unknowns. So let's start with what is biochar. Biochar is essentially pyrogenic carbon, which means it's basically a carbon feedstock that is burned in a low oxygen environment. It's not unlike charcoal, although it's very different. And I don't want anyone to get the idea that you can add charcoal to the soil and it's going to have the benefits that biochar will. Charcoal is a pyrolysis product from wood, but it's meant for barbecues, and they produce it to have certain volatile and flammable components in it that are ideal for barbecuing food, but not adding to soil. It's a plant material that's heated in the absence of oxygen. As a byproduct, it produces biogas, which is a beneficial product. And in some industries, actually, the biogas is the main product and the biochar is a byproduct. And they've just found that it's a beneficial product that they can use to add to soil. It produces a high carbon residual solid. And the main thing that the origination of the concept for biochar was that it's manufactured with the intent to add it to soils for beneficial purposes. It's now being used in other things, and as a matter of fact, we're using it in water treatment. It's used to create. There's one company producing it to add to iron to produce steel. There's a big interest right now in using biochar to add to asphalt to pave streets. You can purchase biochar in large volumes. So here's these super sacks of biochar you can purchase and with the intent to add to soil. And some of the potential benefits of biochar. Here, this schematic kind of captures the whole biochar process with adding agriculture and forestry waste undergoing pyrolysis. Then you add the biochar to the soil. And it provides a habitat for soil microbes. It increases soil moisture retention and improves soil fertility. And these are all biochar may, an emphasis on the may, increases water holding capacity, increases nutrient availability, improves soil aggregation. It may increase soil biota. It may retain nutrients from leaching, sequester and reduce greenhouse gas emissions, and overall increase soil health and plant productivity. And these are all really good things, and it's very promising. However, it's a little bit more complex. And I think one analogy that's I recently heard is biochar is analogous to a coral reef in the ocean, where we think of coral reefs as really highly biodiverse areas with a lot of life. And biochar is analogous to that. And when you put it in soil, it is a substrate that can really promote the development of microorganisms and foster a lot of healthy processes that improve soil quality. So that all sounds great, but it really, what you have to realize is that biochar properties are highly variable, and the result is going to depend on two factors, really. In this slide, I'm going to cover some of the properties of the biochar, and it also depends on the soil, which I'll show you in the next slide. And so here's some micro images of just different biochars, and every biochar is going to look different. I mean, these are very small micron scale features that you're looking at in biochar. It's it generally tends to be highly porous material, which is one of the factors that's important for creating the properties that we might be interested in fostering in soils. It's this high porosity. And so in this table, it's taken from a paper called Biochar Physical Chemical Properties, Pyrolysis, Temperature, and Feedstock Kind Effects. And this table actually, it's only a part of the table. It's actually 3 pages long. And so in this left-hand column, it's showing the different biochar feedstocks. So this is what you're making the biochar out of. And you can make it out of anything. For example, in this table, it's showing peanut shells, dairy manure, feedlot manure, poultry manure, swine solids, turkey litter, fruit tree trimmings, straw. I mean, it's made out of any type of plant material or also manure material. Anything that's got a lot of organic carbon in it, you can turn into biochar. But how you make that biochar, so in this column, it's the temperature of production. It's usually 300 to 700 or 800 degrees. So the temperature that you produce it and the amount of oxygen present is going to cause different products. Take, for example, here, a peanut shell used as a feedstock to produce biochar, one at 300 degrees versus 700 degrees. If you go over here and you look at something like the pH of the resulting biochar, it goes from 7.8 to 10.6 just by changing temperature. And you look at this property surface area. It goes from 3.1 square meters per gram to 448.2 square meters per gram. That's a huge, over 100 times difference in surface area just by the production temperature. And so I'm not going to go through all of these different properties. My main point is to illustrate to you that biochar is highly diverse based on the feedstock and how it's produced. So you end up with 2 important characteristics or ways to characterize the biochar. One are the physical properties, and what I'll show you in the next slide are the chemical properties. So it characterized biochar based on its bulk density, the particle size, is it, a fine powder or larger chunks, such as shown in this picture. Macro and micro porosity, so that's the amount of pores in the biochar, which is really important for its properties. The specific surface area, the hydrophobicity, does water attracted to it or repelled by it? Its water holding capacity, and is it able to be ground up into smaller particles? Some of the chemical properties that are important that determine its persistence, the hydrogen to carbon ratio. So that's the elements hydrogen, carbon, and what's the ratio that determines how long the biochar might persist. The soluble organic compounds, toxic compounds such as polyaromatic hydrocarbons. If there's a lot of these in the biochar, when there's been some studies on if you use a biochar that has high PAHs in it, it'll actually be detrimental for plant growth. So this is an important characteristic. Heavy metals that are in organic feedstocks, they don't usually get volatilized, and they'll be retained in the biochar and sometimes concentrated. So this is important. The macronutrient content, nitrogen, phosphorus, potassium, sulfur, calcium, magnesium. The micronutrient contents, the overall fertilizer value and nutrient availability. So it's one thing if the nutrient is in the biochar, is it available? pH, it's really important factor of biochar. Does it have some potential to increase soil pH? In other words, a liming value. The electrical conductivity, this is basically the amount of soluble salts in the biochar. If you have a soil that has a lot of soluble salts and you have a biochar that has a lot of soluble salts, you don't want to increase soluble salts in the soil. That would be detrimental for plant growth. The cation exchange capacity, this is the ability to sequester cations on the biochar surface, and the alternative would be anion exchange capacity. So those are the physical and chemical properties that are important in biochar. So about all of these factors of biochar, what you might be asking, well, is it good for soil and plants? Well, it depends. It depends on the soil properties. Things like, is the soil acidic or alkaline? What is the mineralogy of the soil in terms of the clays and sand and the iron oxides or other minerals such as calcite? What is the nutrient availability in the soil? If you already have a very high nutrient rich soil with a lot of organic matter, biochar may have less of a beneficial effect. And then biological organisms, including the plants that are in the soil. It depends on the climate. Is it wet or dry or hot or cold climate? And it depends on the type of biochar, which is, as I discussed, dependent on the feedstock, the pyrolysis, the amount of aging, or has the biochar been sitting around for years or a week, and what you do to the biochar called post-treatment. And this can be really important, and we're doing some of this in our use of biochar to functionalize it and make it more active for what we want to use it for. And it depends on your desired outcome, crop productivity, soil carbon storage, and short or long-term benefits. So to get a little bit more data on the effect of biochar on plant productivity, here's a really interesting paper that came out in 2020, so it's recent. And what they did is they looked at, it's called a metadata analysis. They looked at 1,254 paired comparisons of biochar amendment to soil that came out of 153 different studies. And they looked at the effect of the biochar properties and the soil conditions on the plant growth. So it's a really extensive study to have this, 1,254 different biochar amended soils. And so these are the effects of the biochar properties on plant growth. So here on the x-axis is the percent change in plant productivity. So this would be plant biomass or grain production or root production. So this is the percent change in productivity. And then on this axis, it lists the different biochar properties. So the biochar pH, the cation exchange capacity, the amount of ash in the biochar, the surface area of the biochar, the total carbon in the biochar, the bulk density of biochar, total organic carbon in biochar, the total nitrogen, and then what also some people like to analyze, the carbon to nitrogen ratio in the biochar. And then these numbers on this axis, for example, here, pH, this number right here would be the biochar has a pH of less than 7. And then the second number is there were 53 soils that had that pH that came from the number in parentheses is the number of studies. So pH less than 7, 53 soils, 10 studies. So let's just look at a few of the some of the information on this. Overall, of these 1,254 biochar amended soils compared to an unamended soils, there was an increase in plant productivity of about 16%. And so that's this value right here. Now you can break this down and look at, well, let's look at some of the extremes. For example, pH. The soils that had pH less than, or sorry, the biochars that had pH less than 7. This is not the soil pH, the biochar pH. If the biochar pH was less than 7, there were 53 of them. Then the plant productivity actually, it decreased plant productivity. And so this would be an example of the importance of understanding the source and the type and the properties of the biochar. If it has low pH, chances are you're going to get less plant productivity. If you look at the total carbon, in this case, carbon greater than 30, I don't recall the units on that, but it's in the paper. Carbon greater than 30, you would on average get an increase, carbon greater than 30 in the biochar, on average you would get an increase over 80% more plant productivity. If the biochar has high CEC, you can, on average, had about 40% increase in plant productivity. And finally, if the total organic carbon in the biochar is more than 60%, then actually it really has a very small effect on the plant productivity. And so this information highlights the importance of understanding the properties of the biochar. Well, let's look at the soil properties instead. Okay, so this is the same type of graph. On the x-axis is the percent change in plant productivity. And here's our 16% on average from biochar applications. So that means adding biochar in on average increased plant productivity by 16%. And then instead of biochar properties on the y-axis, now we have the soil properties. And so when biochar was added to for example, right here, a soil that had a sandy texture, then the average productivity of the plants increased by 20%. Okay, so we can go through and look at a few of these that were really standouts. If the soil pH was less than 6, then the biochar had a pretty good increase in plant productivity here, about 25%. If the soil had a CEC that was less than 10 milliequivalents per kilogram, then the biochar was a beneficial amendment and actually increased the plant productivity by 30%, as opposed if the soil already had a very high cation exchange capacity, then adding biochar had much less of a beneficial effect, and actually it's close to 0 on average, but in some cases even decreased the plant productivity. So it's really important, the point of these two figures is to take into consideration the biochar properties and the soil properties to understand if there would be a beneficial effect. This is one of the most comprehensive papers, I think, and it's just out. And so it really, I think, summarizes the effects. And I think what you can see is that, in some cases on the previous graph, the scale was extended to 100%. But in general, the average is about 16%. But that's going to depend on the soil and the biochar properties. Another interesting aspect of biochar addition to soils is it provides an opportunity to sequester carbon. One study that just came out in 2020 indicated that the maximum sustainable carbon drawdown potential of biochar by adding to soils over the course of a century could account for one third of the 1,000 gigatons of CO2 that needs to be removed from the atmosphere. So they're really looking at this as a technology. By adding biochar to soil, you increase soil health, but you also promote carbon sequestration. As a matter of fact, just the other day on my news feed, this came across. It says the first farmer in the U.S. to sequester carbon for cash earns $115,000 for his planting strategies. And this was conservation planting that the farmer was using. But with the policies that are coming out, by adding, using technologies such as biochar additions, they're trying to promote this, and there is a way to offset some of the cost of adding biochar by tapping into some of these types of government programs. And it's not a new technology. Biochar, for over 1,000 years in the Amazon, they've been, the native societies there have been amending soils with charcoal. So you can see here's on the right-hand side, this Amazonian soil. It's classical, has these red iron oxides in it. And then on the left side is one of what they call that's called terra preta, which is Portuguese for dark earth. And it's a soil that has quite a bit of biochar that's been added over centuries. And it's not just a small area. This is actually estimated to be somewhere between 6,000 to 18,000 square kilometers of the Amazon has these terra preta soils. And so what the Amazon cultures have recognized that in order to grow food on these soils, that you need to do something to them. And they've discovered and utilized biochar amendments. So it's not a new technology. It's been used and famously in these terra preta soils in the Amazon. And so now I want to switch gears a little bit. That's a lot of background. I want to go into some of actually the experiments that we're doing. And what we're doing is we nicknamed it, it's called this New Terra water treatment process, or we also call it NewTech. It stands for Nutrient Energy Water. And what we're doing is we're coupling biochar with a water treatment process. And this is our pilot trial treatment reactor. And we add biochar to it and treat the water. And in so doing, so this schematic illustrates that you take dirty water or wastewater and you add it to our treatment process with the biochar. The biochar is made from forest and agricultural waste. And out of the process, you get clean water, and then you get the biochar that's now enriched with nitrogen and phosphorus and can be used as a fertilizer. And this mimics processes in nature that by using biochar and iron oxides, which is a natural mineral that exists in soils, we can treat the wastewater, and you can. It's not only used on wastewaters, but we also are going to do some trials on natural waters, such as streams and lakes and wetlands. The benefit is that it recycles nutrients. Phosphorus is a limited resource that's mined from a few places in the world, and nitrogen is fixed from the atmosphere. So um, it's really beneficial to recycle those. Currently, the end of life for phosphorus and nitrogen is in natural waters. So it goes down into the streams, the lakes, and the oceans and creates algae growth. You have these huge hypoxic zones in the Gulf of Mexico, and it really decreases water quality. And so by using what we're trying to do is capture the phosphorus and nitrogen and recycle it. Phosphorus is a limited resource. There's only so many places, excuse me, there's only so many places that you can mine it. And so by recycling it, we can reuse it and prevent it from going into the surface waters. And so here's some images just of a wastewater treatment plant, and we've deployed our pilot trial system, and we're recovering after we use the biochar. This is biochar modified with iron oxide. After we use this in the water treatment, we recover it, and now we can do trials by adding this to soils to test if it has any benefits for plant growth. And so I'm going to go through some data. The first graph, we're just looking at the total nitrogen, phosphorus, and potassium content of the recovered biochar. Again, we call this New Terra as one nickname we use for this. Nitrogen, phosphorus, potassium are macronutrients, so it's important to characterize the biochar and see if we're recovering these elements. And so these three graphs, here we have nitrogen, phosphorus, potassium, and then on the y-axis is the amount in milligrams per kilogram, and then here's the different biochars that we're testing. And we're testing these against a potting soil, because you're going to see in the next graph we did a greenhouse trial. So this biochar, it actually came from a company called Coolterra, which is no longer in existence actually, but that was the name of their biochar. It's essentially the raw biochar. And then we modify it with iron oxides, again, just a normal mineral that's in soils. So we modify the biochar to increase its capability to remove phosphorus from the wastewater. And then once it's been used in water treatment, then it's called the New Terra, and then we're comparing that to a potting soil. So if you look at the nitrogen, the New Terra has quite a bit more nitrogen than the raw and biochar and the potting soil. If you look at phosphorus, several times, I mean, it's really loaded. By going through using it in the wastewater treatment plant, we've enriched it with nitrogen and phosphorus. While potassium, it seems to have lost some potassium in its use in the water treatment. So we did a greenhouse trial. We grew tomato plants. We used this potting soil. We used the micronized or this Coolterra biochar as the raw biochar. And then we did a trial where we used just the iron modified one, and then the New Terra, which is the iron modified biochar injected into the wastewater treatment process. We added them by 10% to the potting soil. We used a fertilizer amendment. It's a Miracle Grow slow release flower formulation. We used this because it had a nitrogen phosphorus ratio that matched the New Terra. And we grew tomato plants, an early girl variety tomato. And it was set up as a 3x3 randomized block design, 3 replicates, 3 blocks. And we grew the plants for 35 days, and we watered them as needed with minimal leaching. Then we measured some of the plant quality measures. We measured the color of the plants using a SPAD meter. It indicates the nitrogen status. We measured the height of the plant, how many buds the plant had on them, the overall biomass, and the overall plant quality rated 1 to 5. And so these next figures, I'll go through some of these results. So let's talk about plant color. And this is measured using a SPAD meter. And then, so you can see here in this picture, 2 plants. One's much lighter green, one's a very dark green. And these are the data for the SPAD meter reading. A higher reading means more greenness. And so this potting soil, nothing in it, had a reading about 30. When we added just raw biochar, it actually was similar or a little bit less. The iron modified biochar seemed to stimulate a little more greenness. When you add the commercial fertilizer, the Miracle Grow, that's here. When you added biochar plus the fertilizer, it got much greener. And then here's our recovered biochar from the wastewater treatment. And then in this bar is the recovered biochar from the wastewater treatment and the fertilizer. And so what you see is really the greenest plants were the biochar amended soils. So let's look at plant height. As you can see, some of them here on the left, this is pretty pathetic looking. Here on the right, it's very tall and vigorous. And if you look at plant height, the raw biochar here, about 10 centimeters. The fertilizer over here, you got the plant grew to almost 30 centimeters when we added the biochar and the fertilizer. It was similar. We didn't see any, the plants didn't really get any taller, just with the raw biochar. And then our wastewater treatment recovered biochar, it actually decreased the plant height. And then the Nuterra plus the fertilizer. So this is the wastewater treatment recovered biochar and fertilizer. We got back up plant height to about 25 to 30 centimeters. If we look at the number of buds, the plants did bud out, which this is kind of interesting. Actually, one thing that the plant scientist would have probably told us ahead of time, but I'm a soil scientist, but is that when plants get stressed, they often bud out. So it's not necessarily an indicator of overall plant health, but it's when you're growing plants for production of fruit or grains or vegetables, buds are an important thing. So the plants that were planted just in the potting soil or even just with biochar in them, they didn't have hardly any buds on them or pretty much no buds on them. They really only the plants that had fertilizer and some type of biochar, whether it was our recovered biochar or the recovered or just the raw biochar here, they're the ones that had the most buds on them. In terms of overall biomass, it really was the fertilizer and the recovered or the biochar or the recovered biochar with fertilizer that had the most biomass. We really got a range of different sizes of the plants. And then we ranked the plants overall quality on a scale of 1 to 5. You know, you can see this here. 1, it's pretty pathetic. 2, it's not very big, and it also has quite a bit of yellowing. Not quite as big, darker green. But here we're nice, big, full plant and nice greenness. So we rated them. Really, the potting soil and the raw, when only added raw biochar to the potting soil. Pretty low plant quality. These plants that were fertilizer, the plant quality was pretty good. Adding the biochar improved it a small amount, maybe not quite significant, but and adding the Nuterra alone without the fertilizer, you know, it did a little bit. It certainly did better than the potting soil by itself, or even the raw biochar, but it didn't do as good as the trials that had the fertilizer in them, whether it was biochar, Nuterra, or the fertilizer alone. And then if you look at the biochars themselves and the available nutrients, so we have ammonium, potassium, and nitrate. So this is what we extract the nutrients from the biochar. And so the Nuterra had a lot of ammonium in it. This is our biochar recovered from the wastewater treatment process as compared to the raw biochar or the potting soil or the biochar that only has iron modification. Again, it appears we lost potassium when the biochar goes through the water treatment process. And that's probably because potassium is pretty soluble and it just leaches out. And we increased nitrate. So we increased nitrogen and ammonium in the wastewater treatment process. And then phosphorus, which is really the main element that we're targeting for recovery on the biochar. And so this is an estimate of the plant available phosphorus. And the raw biochar, it's a lot of available phosphorus. In the actual wastewater treated biochar, it has very little extractable phosphorus. And this was really interesting because it actually has more total phosphorus in it. It's just not extractable. And we think this is one of the aspects that may have inhibited the plant growth some because the phosphorus is there, but it's just slowly plant available, which that can be a good thing because a lot of times traditional fertilizer phosphorus added to soils ends up leaching out of the soil. And so this material, it has the phosphorus in it, it's just slowly available. So what we need to do is find that right balance between slow availability and enough availability for the plant. And so we're continuing these experiments. We've just completed a study on the effects of biochar on lettuce growth. And so we had various treatments and monitored the same properties in the lettuce growth study. This data analysis is just in progress. And so the future research objectives for this biochar, water treatment, nutrient recycling, and plant growth study, we really need to develop some slow release fertilizer tests so we can have, a greenhouse study is great, but it takes about 8 weeks of growing plants. We need to have something that we can get an assessment of availability of the nutrients from the biochar using some type of quick but accurate extraction test. We're going to conduct trials using different amendment rates. We're going to measure the effects of different biochar on soil water holding capacity. And we're going to optimize the biochar for slow release phosphorus. We're going to recover nutrients on biochar at a dairy operation. So we have a pretty large project where we're trying to treat dairy effluent and produce clean water and recover the nutrients from the dairy waste. We're investigating the use of microbes to enhance phosphorus release. And we're studying nitrogen release and mineralization from the biochar. And we need to test how the biochar can be pelletized for application. So what are my recommendations at this point? Is do the cost analysis. There are some benefits, but it's not cheap. Right now, it's about $1,000 for a ton of biochar. You need to, it's really a long-term benefits. It's not something that you're really going to get a return on right away. You need to start small, look for ways to increase cost efficiency, like what we're doing. We're using recycling phosphorus and nitrogen, which makes the biochar a value-added product to add to soils and get more value for the amendment. And really, biochar, it's a co-amendment. It's not a replacement. You can't add biochar and think you don't need to add fertilizers. And really, our research, we've got about 5 years of funding right now that we're working on projects to really continue to develop this product as a value-added biochar and recycle the nutrients from wastewater. So a few final points is, we're in a revolution. There's lots of unknowns. Agriculture is changing rapidly, both in how we manage and what we do to agriculture. And soil is an important aspect of that. Science and industry will drive new knowledge and create improved manufacturing and targeted application. And biochar does have a future in small and large agricultural applications. and it will be a part of the solution to feed the world and increase sustainable living for a positive future. So with that, I thank you. I'm happy to answer questions. I put up this quote. I just was listening to an interview of Elizabeth Colbert, who is a author that's written a few books on sustainability and global challenges. And I thought this point was really poignant. I look at it both as a warning and actually uh, uh, some hope.
Thank you, Dan. That's a great quote to lend. I know we have one person that is on the phone today. So the quote says, "At no point in history have we known more about the threats to our future and had the ability to change it." So thank you for that. We do have a question. And the first question is, are there any concerns about pathogens in Nuterra that were pulled from the wastewater?
Yeah, that's an excellent question. We there are actually, and not only that, not only pathogens, but also there's a lot of compounds in wastewater that are undesirable, such as uh, uh, pharmaceutical compounds, etc. And we've done some studies in our process. When we treat the wastewater, we use what's ozone, which if, not to get into the chemistry, but essentially it's a highly oxidizing gas um, it has no toxicity, but when we add it to the water, it basically busts apart everything. And so we've done tests. We've characterizing the microbial um, microbes that are in the recovered biochar, and I mean, it's 99.99 reduction in E. coli as an indicator species. Basically, we've killed all the microbes, and we've sent samples out for measuring some of these pharmaceutical compounds, and we're getting 70 to 90% destruction of the pharmaceutical compounds that were recovered in the biochar. So we think if it's a wastewater treatment facility, I think it is important to use ozone. And if you're treating a pond or a stream or a wetland or even some other waste types of wastewaters, perhaps a dairy effluent, um, ozone may be optional. It depends. But that's an important consideration, and that's why ozone is an important part of our wastewater treatment process.
Thank you, Dan.
Sure.
Another question that came in is, do you have an idea of the quality you can get from homemade biochar production systems? For example, a double barrel design.
Yeah, I'm really not an expert on biochar production. I mean, I had one experience. I went out with the Forest Service, and they wanted to see if we could produce biochar on site in the forest to use for some land reclamation. Um, and with mixed success was my experience. But for our studies, we were there's a lot of companies out there that are producing biochar, and so we're trying to access the biochar from these companies. But there is a lot of interest in people, biomass. I mean, farmers have leftover biomass. Forestry creates biomass, and there's a lot of interest in people producing it, and there's a lot of people doing it. And I would say the quality of that biochar for soil amendment ranges everywhere from very poor to very good, depending on the feedstock and the production process. Um, and I think, what my experience is, you have to be careful, and it's just not all biochar is created equal and is going to be beneficial for amending to soils.
So one option might be to look at that article that you referenced for this listener. that you might
Mhm.
look at that article that was referenced during the presentation about the feedstocks and the temperatures to kind of get an understanding of the variability. And then perhaps do a literature search using a search engine like Google Scholar with your keywords to see if there's some, refereed, reviewed research that's looking at that particular system that will give you an idea of what you might see come out of it.
Yeah.
And this leads to another question, Dan. And are there rules for biochar products that are available commercially that help you understand what the feedstocks are? And is there any common analysis that might be, listed on the package in the label?
Um, that's a really good question as well. I think what my observation is that the companies are pretty transparent. If they're not transparent, that's probably not a company you want to do business with. But they're pretty open to their feedstock and how they're producing it. And a lot of them that are more developed are reporting properties and even some test trials. Um, However, I, I'm not an expert on fertilizers per se. So I know fertilizers have strict rules for reporting the fertilizer contents, and I don't know if biochars fall under that same those same rules, or if they're more considered alternative amendments at this point. But it's I think it is an important factor to know the properties of the biochar. I mean, I've seen some companies and basically they say the biochar will do everything great, but I don't really see a lot of information to back that up. Um, and not to say, I mean, I'm sure it will do some good things, but maybe not the bang for your buck might not be quite what they're purporting. Um, so um, that's why, like I said, it's just in the last 6 weeks, over 200 papers have been published on research on this. It's just such an active research field, and that's why I termed it. We're in a revolution, but especially with things like biochar amendment, it's just very active field. So as a grower and a producer, you're kind of you're amidst that revolution. It's a little bit of a high risk proposition, but it could have some benefits, and I think it does have a future. It's just if you want to be in a little bit more secure of a position for this decision making, you do small trials and do your homework. Is my recommendation.
Yeah, absolutely. And I would suggest contacting any company that you plan to purchase biochar from and asking if they have some supporting research or documentation that backs up the claims that they have. Another question that came in is, what is the ratio of biochar needed for wastewater cleaning to produce Nuterra? And is that ratio sustainable?
Trying to remember, it's the grams per gallon. Yeah, it's a pretty small amount. I don't remember the exact number. So it would be something like I'm just going on kind of what my visual is thinking on this. We have the numbers, I just don't remember them. You might think of like a 5 gallon bucket. You might put in a teaspoon of biochar. So it's pretty small and it's actually very effective. And actually, in one sense, that's in turn for us. If our main goal was to recover biochar, we'd want to add more. But our main goal is to clean the water. We have to produce clean water, um, and uh, and then the recovery of the biochar is a byproduct. And so to get just to get a kilogram of biochar, we might have to run for 8 to 10 hours of processing. Um, so
Thank you. This is a fascinating area of research. I'm really excited to
mhm.
see how this progresses and looking at this potential to clean water and provide a soil amendment is pretty exciting. I really want to thank you for being with us today and sharing all of this great information and resources. Again, to let everybody know that we will be posting the slides from this presentation at our Cultivating Success website along with a recording. We do have an evaluation that we would really appreciate your completing. It is going to launch in your browser when you leave the webinar, and it's also going to be available through that slide deck. So what's coming up? So next week, we are going to have a presentation on vermicomposting, looking at vegetable kitchen scraps to usable compost. And then March 1st, we're actually going to have several programs about soil and water, but specifically in this webinar format, you'll be able to watch Choosing the Best Irrigation System for You. Just to let you know, that March 2nd date is going to be posted along with the other Soil and Water Week programs on the Cultivating Success website. And then moving into March, our theme is going to change to look at pest management and pollinators. So we hope that we see you on one of these upcoming webinars. Again, Dan, I want to thank you for a great presentation today and sharing your research. And, thanks to both you and Dr. Moeller for the amazing work that you're doing and your leadership in this field. Thank
Yes,
you.
thank you. I appreciate the opportunity. And if anyone has any questions, feel free to contact me.
Absolutely.
Thank you.
Okay, everyone, have a great day. Be safe in the snow, and we hope to see you on another webinar soon.